right, good afternoon, everyone. I'm excited to be here today. My name is Patrick. I founded an analytics company called Broadband Insights. We're here today to talk a little bit about what we'll call vibe analytics, kind of how we work with our customers, a little bit about the back and forth process and how the exploratory analysis works and kind of what we've seen in real world scenarios. I'm not a data scientist, but we kind of can see the value that this can provide and kind of in the exploratory phase, talk with real people with real problems. Yeah, a little background on our company. Basically, for those of you that don't know much about broadband or fiber optic connectivity or any of the thing that's going on right now, there's a big digital divide in the US. It's a known problem. There's a lot of federal programs that are putting money into it. So some of the larger incumbents are expanding their networks and a lot of smaller regional providers are trying to basically fill in the gaps. This could be dense urban areas where the infrastructure is old and the financials don't make sense for an incumbent to upgrade service, or in really rural areas where a home may be too far out, where it might cost $8,000, $10,000, $12,000 to kind of connect one home. So there's a lot of public money right now with the BEAD program, about $42 billion in the US, and there's a lot of private money behind that trying to solve this problem. So with a lot of money investment comes a lot of analysis, and most of the decisions that telcos make is based on real numbers and analysis. So anything to do to make the analysis easier by collecting better data, having better quality of data, or being able to dig into the data is very, very valuable to these types of clients. So basically our goal, we want to connect the unserved, underserved. We support broadband providers, construction companies, and private equity or other investment firms in this space that are trying to basically fill in the gaps in the network. We work a lot on building out these fiber networks. They're very capital intensive. Again, there's billions of dollars being spent on expanding these networks, and then the actual connectivity portion of it, connecting a fiber network is a graph problem of you have to actually build a network, it has to connect in various ways. There are breaks in the network. It's not as simple as circling an area and saying build this. So there's a lot of detailed analysis, that's spatial analysis, graph analysis, on top of just looking at spreadsheets and balancing your budget and EBITDA. So basically we work on all sides. We say plan, operate, and build. We're going to help kind of analyze the financials before going into a network, maybe trying to find the best places to deploy or the best speed to deploy. We keep track on construction or where your capital spend is going, give more insights into how it's going. Maybe things are going well, maybe things are not going well. And then all the way through sales and operations, where you actually have to get customers on board, make sure they're happy, making sure your technicians are getting to where they need to go on time, and that ultimately your net promoter score is where it should be. And there's a couple of metrics on the board just to give an idea of how big this problem is outside of just the large providers that serve a lot of the country. So the FCC does all the reporting analysis on what's considered served, underserved, and unserved in the US. And at this point, a lot of money has gone into the past few years. It's much better than it was 3 or 5 years ago, but there's still 7.2 million homes right now that are classified as unserved or underserved. An FCC definition of that is 100 meg per second, which is still not like super fast. And then 26% of homes in the US actually only have access to one provider. So if we say they are served, they can get 100 meg, they may not actually have the choice to pick a provider. So they could be in a monopoly where their prices could go up or prices could go down. So for data analysis, again, these competitors may go in and see a gap in the market. Well, there's only one provider, it's a cable company that's not gonna expand their network. I bet if we raise $50 million, we could go compete with them and make our money back. So helping on the financial modeling, tracking metrics throughout the build, and then ultimately managing their books long-term. And then the CapEx that's being committed. So again, the federal BEAD program right now is $42 billion. If you add on private dollars on top of that, basically private investment will go in and try and jump on the money, match or increase. So a study by the RVA basically said within the next 5 years, $167 billion is gonna be spent in this space. So that's kind of our business. That's the niche we're trying to provide in the market by finding the people that maybe don't have a data science department. They are looking into a niche part of a build. We collect data, collect daily, monthly metrics, key KPIs. We clean the data, we snapshot it, we do a lot of time series analysis, and then a lot of the front end dashboards reporting are what most people see when they think of the analytics. Let's say a couple examples of our classic what we do. This is, again, stuff that takes days, weeks, or months to build, which is the opposite of what we're going to talk about with vibe analytics. So as an example of the type of data that we play with that's kind of interesting at scale is utility poles. There are millions of utility poles in the US. This is an example of a few thousand that we had collected where we're doing a cost analysis. So when you install fiber optic on a pole, it can cost maybe $500 to $1,000 to apply for permission to get on that pole. And then if work needs to happen that pole, like there's not enough space and to meet clearance issues, you have to make the pole taller, move stuff around, it can easily cost $5,000 or $10,000 to reconfigure a pole. So when people talk about bridging the digital divide or building these networks, a lot of the problem is with permitting and things like getting the pole owners to actually make space. So again, you can see a small build at $10,000 a pole can turn into hundreds of thousands, millions of dollars very quickly. So basically being able to take a lot of data about the pole. We do some LiDAR analysis, some photogrammetry analysis to look at different heights, thresholds, clearances, and then add cost modeling for what different configurations would take. And so we end up with this map as an example where we have basically categorized simple red, yellow, green pole. This is really easy to attach to, this is low cost. Yellow is going to be a certain threshold and the red gets very expensive. So we can kind of run a graph analysis on this to find either the most optimal routes to build or decide that something doesn't financially make sense and the provider would have to do a different approach. And then the other one that we do more of is working with investors or private equity groups or operators that have to report numbers back to their investors is calculating metrics on a monthly basis. So it's probably used to like MRC, like monthly recurring charges, annual revenue per user, EBITDA, things like that. But we also need a lot of operational metrics on these builds. So how many homes were planned to be passed? How many did we build? What was the cost per foot? How many sales were made? How many scheduled installs? So basically we write the ETL pipelines to capture the data from a bunch of different software systems. We snapshot the data, we keep it in a time series format, and we're able to basically let an investor pull up a view that looks a lot like an income statement where they can look at, their costs, their ARPU, their churn, alongside other metrics like sales, cost per foot, how many homes were lit this quarter. So again, this is stuff that's very structured, very well defined, and kind of doesn't change. If an investor gets a spreadsheet at the end of the month, 3 years, he wants it to look the exact same way. So the fun part now is the EDA, the exploratory data analysis. So one of the big problems with coming up with these production-ready dashboards and things that are very known is how do we get there to start with? And pretty much everyone I've ever met, they love charts, they love dashboards, they love graphs. They'll start to tell me how much they love graphs. And if we talk to anyone, what kind of data do you want to see or what should it look like? The conversation stops or it just goes completely sideways. Someone may remember what a dashboard they saw 5 years ago looked like. They may try and draw it on a napkin. We get some really hairy descriptions of, hey, I would like to know texts per month in this region and this. I think we got a list of 300 just lists of things this person would like to see. And our job is to turn that into, well, we have to figure out what system it comes from. We have to write the code to scrape the data from that system. We have to snapshot it. We have to QC it. And then we have to kind of build the views they like. So we can spend weeks on something. Oh, we built this Sankey diagram that shows your flow of your customers and the different phases they fall off and when they churn. And so one can be like, nah, can I get a bar chart? So we spend a lot of time trying to understand what the customer wants. So with Plotly's AI Studio product that they come out, they gave us early access where we got to start using this with real customers, with real data early on. We'd use some of the legacy products. They were very helpful and useful for this. And the chatbots work really well when you kind of know what you want to get. So you can ask a question, you can maybe have a back and forth. But this kind of analysis just took it to a whole other level. Basically, we can just get as data as simple as a CSV. So talk to a client, hey, this example here is the same pull data set, but let's say, hey, send us a CSV of all your customer packages. And we drop it in and really quickly, it will start to, we'll say, decide what may look interesting. You can give a lot of context or you can give very little context. And the LLMs are really good at interpreting, here's what these columns mean. This looks like this data is about customers and the packages and plans. And maybe you'd want to see a time series graph of what packages are on the decline, or maybe you want to see a scatter plot of different regions where customers are churning. So what's really interesting about the collaborative analysis phase is you don't know exactly what you want to see, and instead of spending weeks talking about a problem or days trying to code a piece to show it to someone, and the gap between the executive that wants a problem solved and the user, the programmer that's actually writing the code, we narrow that gap where they can be in the same room talking in real time. And the vibe part is going to be us working with customers, and obviously talking with the LLM is, hey, actually, this looked really interesting as a scatter plot. Can we make it a bar chart? One of the more interesting things we saw with the diagram on the screen is we took that same poll data set where we have maybe 5,000 polls where we've done a lot of clearance and structural analysis. And it generated a map, which is great. I mean, it generated a map. I didn't have to code a map. It was there that had all the classifications. You can zoom, you can click on stuff, or you can slice, dice the data. It started to generate charts I never would thought of. It had a histogram of basically the different clearances or the average separation on different polls. That when you start to see the data in that way becomes really, really interesting. And the big thing, we'll talk about what Vibe Analytics is on the next slide, is it's not making decisions, it's still kind of prompting like, oh, here's this thing. And you can really quickly say, no, actually, I don't want that. That's nonsense. But could you make something like this? It's really, really good. And just the time, this is taking minutes to go back and forth and generate a new graph chart without having to spend like weeks talking to someone, trying to figure out what they want, coding it up, mocking it up, and then ultimately showing something they may like, but they may not like. The second big use case that we're going to be using in the future with we'll call Vibe Analytics is just the mock-up phase. So after going through that exploratory phase where we kind of know this is what's interesting, this is the type of data, like maybe someone had an idea of I really want to know about installations, where we can show them, oh, well, here's the 5 different ways that we can show on-time performance, mean time repair, maybe the volume of tickets per day or the average time to close. We can kind of mock that up and they can say, okay, actually this looks really good. I want this to arrive at 8 a.m. every day. The code is available. We can basically copy that code, put it into production, go through our regular debug, test, commit, and deployment process. So we can go from kind of exploration to a mock-up and then put it into production. And then I think working with Plotly, their long-term vision is really the self-serve of the data. So we do a lot of work to collect and refine the data and QC it for our customers, but still an executive may want to know a question or play with the data, and they're not gonna have the skill set to get into Python or Jupyter Notebook and start coding things. So basically giving the ability where we are able to export from our data lake the type of data that can be brought into AI Studio, where then they can vibe with the data, where they don't need to hand off the work to a developer. And again, it's not something that's going to go into production, but it may spawn some ideas of, man, actually having that Sankey diagram that Patrick said would be great if I had it every week. So for Vibe Analytics, basically the definition, AI-driven code-based approach that allows users to interact with data through the natural language conversations similar to brainstorming. So I think the big critique I've heard of Vibe coding and Vibe Analytics is you can't trust the code. The things hallucinate. They don't know what they're doing. The big difference with this exploratory data analytics or Vibe Analytics is it's really just building code to spec. It's not calculating my customer's churn. It's not trying to decide what average installs per day looks like. It's just using the LLM to generate the code to really visually display that. So it's really good at building the pie chart, building a line graph, doing basic pandas and pollars work. So it's not really doing anything other than speeding up the development process. So the big drivers behind that, and a paper by Michael Schrag from MIT is linked here, but the big drivers are, while BI tools are great, there's still this walled garden. So Tableau and Power BI, they're great tools, but you're very much in their ecosystem. You're gonna have to use their tool set, and you're gonna have to have users that are trained on their tool set. Whereas someone that just wants to go in and maybe just play with data just kind of needs something a little bit simpler or cleaner. And then we all know, this is the reason I'm in business, hand coding is the gold standard. Someone that can get in there and like have a team of people that can actually do that really detailed analysis, take one step and then take it 3 steps further, and understands actually statistics. But not everyone has the time for that, not everyone has the budget for that, and a lot of our customers, they're either smaller providers or they just don't have the investment for data science teams or developer teams that aren't solving other problems. Dedicating people to just that is very tough. And then chatbots, while they're great, they're kind of limited to the imagination of the prompter. I may ask what my churn was like over the past 3 months. It may tell me a number. That may make me think of another question, but it's not going to generally see something that pops out like, oh yeah, here's this histogram of all your data. I assume I'm about good on time. Quick overview of our platform and kind of where AI Studio and just Plotly Dash fits in. We use oil and gas kind of analogy. So typical ETL diagram on the left, we have what we call our data collector, where we handle data ingestion. So we write APIs or other processes to get data out of a lot of these third-party systems. We use cloud tools such as Azure Functions, Pipedream. We've moved to Dagster within the past year. We keep all that data in our data lake. Again, a lot of cloud products, scalable Postgres instances. We used to use Crunchy data. They've been acquired by Snowflake now. We've worked with Cassandra a little bit for some of the wide columns and time series data. We're trialing Databricks now, and that's probably where we're going to go in the future. But basically, we take all that data, we host in a data lake, we replicate it every night to basically 2 databases, one that'll handle the geospatial data, we use PostGIS for that, and just a local instance of Postgres for the tabular data. And then within Dash, we kind of able to cache and refresh that data every few hours. Some of the data is live, some of the data is daily, some of the data is monthly, but the cache kind of makes sure everything's really fast or responds quickly to the user. And then with Dash, we're able to kind of handle apps lifecycle for production apps. It'll handle all their security. That's something we just don't have to worry about. Snapshot Engine is a tool that'll actually let us turn the data into, again, those reports that people want to see at 8 o'clock every morning, 8.5 by 11, 11 by 17 paper reports. But you can also go back and slice and dice data and do analysis. So right now, we take snapshots of a lot of key reports every day. We'll email those out to clients. We'll connect and do notifications. And then the analytics platform is log in. People go and slice and dice data. So what we are showing here now for what we're going to do for Vibe Analytics is basically allowing the users to export that data directly through Dash, so we can use it with our tools and let those customers vibe with their own data. These are just results of what we have seen with our customers on kind of having data analytics versus not. There's like real money to be made on these projects. There's cost savings on these projects. And that's it.